Hello everyone, we are Molecular Simulation Group by Professor Jihan Kim at the Department of Chemical and Biomolecular Engineering. Our group is often called MolSim, which means the molecular simulation. As you can kind of guess from our name, we focus on computational simulation and modeling to study energy-related problems. For example, alternative and sustainable energy materials. To summarize, we study macroscopic phenomena in scale of microscopic molecular units. Today, we'll briefly introduce who our PI is, what we've studied, and our lab equipment. Our PI is Professor Jihan Kim, as shown in this picture on the slide, and he's from America and came to Kaist as a professor in 2013. One unique thing about him is that he has electrical and computer engineering background, and this is why our group can gain computational aspects of research in chemical engineering, which is kind of unconventional. His research interests are carbon capture, methane hydrogen storage, screening of porous materials, and molecular simulation like Monte Carlo and molecular dynamics. As mentioned in the previous slide, one of our main research fields is to study porous materials like zeolites and metal organic frameworks. These types of porous materials work as fishnet so that they can capture or store target gas molecules. Some of the examples for applications are carbon capture and sequestration, and methane and hydrogen storage. Our group used the computer simulation to perform virtual experiments to predict behaviors of the materials, and this is not only time and cost efficient, but also much safer because we perform the virtual experiment under harsh environment, which can be extremely dangerous in real life. Another research focus is to study high-performance computing. We develop GPU code to perform absorption simulation and find suitable materials for targeted application.
Also recently, our group has gained interest on artificial intelligence and machine learning. Advancements in AI research are predicted to impact every aspect of our daily lives, and it is conceivable that the way we conduct research will change with the help of an AI. In our research lab, we seek ways in which AI and deep learning can help us develop new materials, leading to better absorbents, catalysts, and batteries for the future. We also seek to develop various different softwares that we use in our lab. Our in-house developed codes include GPU molecular simulation code, IAST builders, polymer builders, various neural networks, text image mining codes, and metal organic framework builder. We seek to build a library of codes and encourage, as this is becoming more and more important skills for chemical and biomolecular engineers. We had talked about our lab's research so far, and now I'll introduce our group's equipment. Different from most of labs, our group doesn't do any experiments, and so we don't have a typical lab setting. We have computers, softwares, and servers for simulation and calculations. The figure here shows a picture of our server room with the detailed specs for our equipment on the right. And this is our main workspace where plenty of individual spaces are guaranteed. Basic computers and software settings will be given, so you just can't come to our lab free-handedly. And this is our seminar room where we hold meetings and share our ideas and progresses. We welcome new recruits and would like to hear from you guys, so feel free to contact us. Our contacts could be found in our molecular simulation group website. And that was a brief introduction to our molecular simulation group. Thank you for listening and hope we can hear from you guys soon.